um, all matter is composed of basic building blocks called atoms. And what is atom made up of? It is made up of electrons, protons, and neutrons. The central part of the atom is called the nucleus, and in the nucleus we have protons and neutrons. Protons are positively charged and neutrons have no charge. And where are the electrons? Electrons are revolving around the nucleus in these different energy levels, which are also known as principal energy levels. And electrons, they are negatively charged. Atom is neutral. Why? Because the number of protons are equal to number of electrons. Protons are positively charged, electrons are negatively charged. These two terms, the first one is the atomic number. Atomic number is denoted by the letter Z, and it is the number of protons. Mass number is denoted by the letter A, and it is the number of protons plus number of neutrons. For example, let's talk about the element sodium. And if it is sodium, if we write down like this is the atomic number and this is the mass number. That means an atom of sodium has 11 protons, and this mass number is the number of protons plus neutrons. So it has total protons and 23 protons and neutrons. If we know the mass number and the atomic number, we can find the number of neutrons by mass number minus atomic number, and that gives 12. Going back to the electrons, there are electrons, they are around the nucleus in different energy levels, which are also known as principal energy levels. So let's say this is the nucleus and these are the different energy levels, and we can label them as 1, 2, 3, 4. The first energy level is closest to the nucleus. Electrons love to stay close to the nucleus because nucleus is positively charged because it has protons. So electrons love to be close to the nucleus. But if this energy level, the first energy level is complete, then the electrons go to the second. When second is full, then they go to third, and so on. So let's talk about again the energy levels. These principal energy levels, they're also known as energy shells, or I can just use the word shells. So shells, first shell, second shell, third shell, fourth shell, and so on. These shells are further subdivided into subshells. So the first shell is further subdivided into one subshell, and we denote it by 1s. Second shell is divided into two subshells, and they are denoted as 2s, 2p. Third shell is further subdivided into three subshells, and they are denoted as 3s, 3p, 3d. Fourth shell subdivided into four subshells, we call them as 4s, 4p, 4d, 4f, and so on. Now subshells are further divided into orbitals. So 1s subshell, if you see the letter s, that is divided further into one orbital, and in each orbital we can put 2 electrons. That means how many total electrons can be in the s subshell? 2. If we are talking about the subshell with letter p in it, then this subshell is basically made up of 3 orbitals, and 1, 2, 3, and in each orbital you can put 2 electrons. That means if you have a subshell with letter P, you can put total 8 electrons. D subshell is made up of 5 orbitals. Each orbital can have 2 electrons. So the total number of electrons in D subshell can be 10. And if you see the letter F, then it is 1, 2, 3, 4, 5, 6, 7 orbitals. Each orbital can have 2 electrons, so 7 times 2 is 14. So the point is, in S subshell you can have maximum 2 electrons. In the P subshell you can have maximum 6, D can have 10, and F can have 14. Electrons love to stay close to the nucleus, as we already discussed it. So lower energy levels, or another way of saying is, electrons love to stay in energy levels in shells that are lower in energy. So when you are filling the electrons, you fill the lower energy levels first. And how will you find out which one is the lower energy level, which one is the higher? You follow these arrows. So you fill first this 1s subshell. Once it is full, then you fill 2s. Once this is full, you start with 2p. Once 2p is full, then you go to 3s. Then you start with 3p, 4s. Then 3d, 4p, 5s. Now one thing is, you're going to say, okay, so we are filling 4s before 3d, even though 4 means fourth energy level and 3 means the third energy level. So, and the main reason is 3d, even though it's one lower energy level, but it is not really lower energy level, because there are more electrons in this D subshell and electrons repel. So that's why the energy of this 4s is lower than 3d. So you follow these arrows, because these arrows tell you which energy level to fill first. And this is what we call it as Aufbau's principle, that you fill the lower energy levels first, followed by the higher energy level. So let's look at these elements, and we're going to write down their electronic configuration, means how are the electrons arranged around the nucleus. So the first thing that you have to do is to find out the atomic number, because atomic number is number of protons, and number of protons are same as number of electrons. If you look at lithium, lithium has atomic number as 3. That means it has 3 electrons. And if I go back and draw all the energy levels and the arrows to show which one to fill first, then lithium, we will start with 1s. How many maximum electrons you can put in the sub level with letter S? 2. So 1s, 2. Once this is complete, then you follow the next arrow, 2s, 2s. But we have total 3 electrons, so only 1 is left here. So 1s2, 2s1. Fluorine is here. Fluorine atomic number is 9. So you start here, 1s2, then you go here, 2s2, then you go to 2p, we need total 9, 2 plus 2, 4, 4 plus 5 is 9. So your electronic configuration is 1s2, 2s2, 2p, 5. Let's talk about bromine. Bromine atomic number is 35. So here 1s2, 2s2, 2p6. What will be after 2p? 3s. S can have maximum 2. Then 3p6. After 3p you go to 4s, 4s2. Then here 3d10. So 2 plus 2, 4 plus 6, 10, 12, 18, 20, 30. So after 3d it is 4p. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. You can also write down this electronic configuration just by looking at the periodic table, because we know in the periodic table these are S block, these are P block, these are D block, and the last two rows separate are. So we can say, let's say if I'm writing for lithium, here is lithium. 1s2, now we are in the second row, 2s, and it's the first one, 2s1. Fluorine is here, 1s2, 2s2. Now we are entering P, we are still in the second row, 2p, 1, 2, 3, 4, 5, 2p5. If you have to do the bromine, which is here, so 1s2, 2s2, now 2p, 1, 2, 3, 4, 5, 6, 2p6, third row, 3s2, 3p6, 4s2. Now when you enter D, you put one less row number. So that's why it means n minus 1. You put one less row number. So if in the fourth row you put 3. So 4s2, 3d10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you are entering P again, 4p, 1, 2, 3, 4, 5, 4p5. Let's look at the last one, which is barium. So here here's barium. So we start here, 1s2, because it's in the first row and both are S, 1, 2. 1s2, these are S, these are P. Second row, 2s2, then 2, these are P. So how many? 6, 2p6, 3s2, 3p6, 4s2. Now we are entering D block, so one less row number, 3d10, 4p6, 5s2, one less row number, 4d10, 5p6. Now in the sixth row, 6s2. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, and 6s2.